Imagine flipping a coin, or if you're rich like me, you can just do it. Now just keep doing this 100 times. An easier way would be to have a program do it for you. Now if we know everything, what each flip is, then that's the microstate of the system. But it's a little hard to keep track of everything like that. So what if we just count how many heads and how many tails we get? That's the macrostate. Now, say every particle in the room has an equal probability of travelling left and travelling to the right. So coin flip odds. What is the probability that every single particle is travelling to the left? What is the probability that I'm going to be left in a vacuum over here? Now there are many ways to make a macrostate of 50 heads and 50 tails. Every second flip could be a head, or the first 50 flips could all be heads, with the rest tails. But there is only one way to make a macrostate of 100 heads. Every single flip has to get a head. The multiplicity is the count of the number of different microstates that make up a single macrostate. Here I am modifying my program to output the multiplicity of each macrostate. As you can see, it's sharply peaked around 50. So if we apply this back to the particles, about half are travelling to the left and half are travelling to the right. There's only a very small variation either side of that. And we never have the case where all the air evacuates the room. Although it is entirely possible, it's just so statistically improbable, it's not worth worrying about. Note that when we are talking about particles, there are far more than 100. So, like in the order of magnitude of 10 to the 23. This peaks the multiplicity even more sharply around the middle. Why is this important? Entropy is, by definition, Boltzmann's constant times the natural log of multiplicity. So when the second law of thermodynamics states that entropy is always increasing, what it really means is multiplicity is always increasing. Not disorder or chaos or any colloquial term that is commonly used. In fact, entropy actually forms the theoretical definition of temperature. Temperature is the derivative of energy with respect to entropy. So even if the system starts with all the particles travelling to the left, there'll be a whole lot of random interactions and collisions which will cause some of them to start travelling to the right, which increases the multiplicity. Entropy increases until it reaches a maximum where half are travelling to the left and half are travelling to the right. That's what is meant by the second law.